All right. So, a couple of things here. We have radians per second, which is velocity, and it comes to a stop. Moment of inertia, right away, there's only one equation that has that in there. And they're looking for torque. Retarding torque is just friction. Yes? The force of that spinning object that brings it to a stop. So our main equation is angular acceleration equals torque divided by moment of inertia. Let's turn that into what we want. We want torque. So that would be angular acceleration times moment of inertia. Couple of problems here. We don't have an angular acceleration, but usually you can get it. And this would be change in angular velocity divided by time. My angular velocity was 12 and it comes to a stop. So isn't that the change? It is. And how long did it take to come to a stop? 160 seconds, which seems like a long time, doesn't it? So 12 divided by 160, which is 0.075. It's angular acceleration. That'd be radians per second squared. So now I have that, and I can put that up here, 0.075 radians per second squared. That's a decimal. That have an I, moment of inertia, is 0.100 kg times m squared. My 0.05075 is already in my calculator. Let's multiply it by 0.1, and let's get a torque of 0.0075. That would be newtons times meters. And let's turn it into scientific notation just to be fancy. It's 7.5 times 10 negative 3, and it's still Newton times meters. Two-step problem, no problem. Bye-bye.